Hello, my name is José Feiteirinha and I will be presenting BigSTRUCTURE, a backend for scalable prototypes. The problem right now is that if you want to scale a prototype, you have to install a huge amount of tools, and you also have to learn a lot about these different tools. And the idea is basically to disable most of this extra work. With BigSTRUCTURE, you have host nodes instead of host names, and you program for hosts. So much like programming for a cluster or programming in a distributed manner, you program for an enormous amount of host nodes, which may or may not be necessarily physical machines. For this, we have what we call the EPUs, or ephemeral processing units. Ephemeral processing units are basically amounts of processing power that exist but are volatile. They can be attached to any host name. It's like as if you have a CPU which was moving between different hosts. Now let's look at an example. On the first line we have ensure host. This basically requests that a certain host name is created, and then requests EPU. So basically this is asking the system, the BigSTRUCTURE, to create an ephemeral processing unit. Right now we have a sleep of 2.5 seconds, but that's temporary. We'll replace it by a wait for EPU. A bit more down you see the while, and this is a count which receives from the command line interface. As you can see on the top, it says it's a number 10, and basically it says it will do the same thing 10 times and send an echo request and print out the result. On the bottom right you can see the echo node and the EPU. This is inside the default BigSTRUCTURE, so each BigSTRUCTURE has its own ID and they can have multiple structures coexisting. You can also see the node data, which basically contains the internal data, which is a host name and a node ID and a port. And that's it. This is the most simple example of a BigSTRUCTURE client. Right now we are calling services to what is run on the ephemeral processing units, but this may change to threads, but at the moment we call it services. And these BigSTRUCTURE services start, as we can see on the top left, with an open, a handle function and a close function. And the open function is done once for the ephemeral processing unit. The handle is called once for each request, and the close when it times out. And basically, if the handle function is not called for a while, the processing unit disappears. This is done by calling the close function. So if you make sure that whenever you close something, you save it, and then whenever you open, you load it, you can basically ensure that you never lose any data, even though the ephemeral processing units may be moving from physical host to another physical host. On the bottom right you have the very simple objects that are sent, so the request object and the response object. Going back to this picture, you can see these blue things as the ephemeral processing units, and they can actually be moving from one place to another. So long as it's providing the service you request, you get the response. However, if it's not used for a long time, it will time out and call the close method and basically disappear and stop consuming resources. Without going into much detail, this is the configuration file. This is used on each physical machine, and this is the only thing that you need to have to run the BigSTRUCTURE. Deployment of BigSTRUCTURE is as simple as starting the same jar application on another machine. Just that. This is developed as an open source project, and you'll be able to follow everything on the link below. And this is the roadmap for the future. Right now we are fixing some things, just as with the ephemeral processing units work, but they are not timing out. Also, we are using sleeps, which is going to be removed. They should all use the wait for EPU. Eventually we'll support multiple ephemeral processing units per host node instead of just one, and we'll add the ability to dynamically submit services, and eventually we'll remove the necessity of Zookeeper completely, at least for very small projects.